All right, so today we're going to take and transfer absolute or do transformations of absolute value functions. So here we show the graph of the absolute value function. The parent function f of x equals the absolute value of x. And notice that all the values are positive, all the y values are positive. So remember that when we take the absolute value of a number, then we get a positive number. We're going to go ahead and do the transformations. So reminder of horizontal transformations and vertical transformations, translations, that if we have a vertical translation, that means we're adding on to the function itself. So that means we would have the absolute value plus. Okay? If it's a horizontal translation, then it's inside of it. So basically, you can think of it this way, that we're talking about when it's a vertical translation of an absolute value function, then we are going to have the absolute value of x plus k. And when it's horizontal, it's going to be an absolute value of x minus h. So the plus k, when it's vertical, is outside the absolute value. If it's horizontal, it's going to be inside the absolute value. So here they want us to perform each transformation and then graph the transformed function. So here it says we're going to move 5 units down. So that means then that g of x would be the absolute value of x minus 5. Because it's a vertical translation, that means it's going to be outside the absolute value sign. So then the graph of this then, just be moving it down 5. And so we're going to take our vertex here at the origin and move it down here. And make sure your graphs are correct. This graph goes up 1 and over 1, which that's not exact. There we go. Oops. Where are we going? There we go. Okay. Pretty close. All right. 1 unit to the left, that means the value of h is what? -1. So then we're going to have the absolute value of x minus a -1, which means then it would be absolute value of x plus 1. All right, so because it's horizontal, it's going to be inside the absolute value sign. Vertical, it's outside. So if we graph this one, 1 unit to the left, then we're going from -1. And that's what a graph look like. But the thing is, you'll notice, is they're parallel. Okay. All right. Right now, these are parallel. They still have the same slopes going both directions. Okay. The vertex of an absolute value function. The vertex for just the absolute value of x is 0, the origin. Okay? But when we move the vertex, we have basically put that horizontal and vertical translations together. So we have the absolute value of x minus h plus k. Okay? So all we've done is taken that horizontal translation, which is inside the absolute value, that vertical translation, which is outside of it, and put it together. And that tells us where the vertex is. So here we have an example where they tell us the vertex is at the point -1, -3, and then we want to graph it. So we'll put -1 will go in for h, and -3 will go into k. So we get g of x equals x. If I'm subtracting negative, that's the same as adding. So we have absolute value of x plus 1, and then minus 3. So when I graph it then, my translation that I'm going to have is going to be 1 to the left and 3 down. So we're going to take this graph and we're going to go 1 left. Oops, I don't want to do that. Let's leave it there. So we go 1 left, 3 down, and start at the point -1, -3. And that would be our graph. So we can see it's still parallel. The lines are still parallel. Right? They're just in different spots. So all we're doing when we know the vertex, putting the x coordinate in for h, the y coordinate in for k. The other transformations. Absolute value functions can also be reflected horizontally and vertically, and they can be stretched vertically and compressed vertically, and they can be stretched and compressed horizontally. And so we're going to look at those. Now the one thing is, if you take the absolute value function itself, if I just take that one and I reflect it horizontally, it's going to look the same. Okay? If I just reflect it over the x-axis, it looks the same, or the y-axis, excuse me. Okay? All right, so here they want us to perform this translation and then graph it. It says reflect the graph of f of x across the y-axis. Right? So if I go across the y-axis, is that horizontal or vertical? Okay. It's horizontal, right? Because we're going this way. Across the y-axis, we're going horizontally. Right? So if I'm going horizontally, that means then I am looking at this one here, which means that I'm replacing x with -x. So we go down here to the function, and we're going to replace x. So to get g of x, we're going to replace x with -x. Okay. All I did is change the x from positive to negative. Okay. Now, let's look at our original one. Let's get our original one graphed here. Okay. So, let's see. So where's our vertex at for the original? -2 or +2, +3, right? Okay. So if we go over here to +2, +3. Right. +2, Okay. There's our original, correct? Okay. Now, if I reflect it over the y-axis, that means then that our vertex should now be where? Okay, -2, 3. So we've got our vertex is going to be here at -2, 3. Right? And that means then my graph is going to look like this then. Right? Okay, so let's check it. So go to your y equals on your calculator and check, see if it works. All right, so we're checking to see if our vertex is in the right spot. Okay, looks like it is. And so I should have the point -2, 3, so I'll hit trace and -2, and I should be at +3. Okay. I could check my y-intercept at 0, should be 5. Okay, so check it to make sure it's doing the right thing then for you. Okay. All right, so that one worked. All right, letter B. says stretch the graph of f of x equals the absolute value of x minus 1 vertically by a factor of 2. Okay, so let me move my graph down here to our center, or to the right vertex. Okay. So we've got that graph, and we're going to stretch it vertically by a factor of 2. All right, so which translation is that, or transformation is that? If I'm stretching vertically, okay, which one of these stretches vertically? Okay, so stretching it vertically is going to be this one here. So we're multiplying the whole function by a. So in this case, we're multiplying the whole thing by 2. So g of x equals 2 times f of x. So we're multiplying the whole function by it. So that means we have 2 times the absolute value of x minus 1. Now, when I distribute the 2, can I put the 2 inside the absolute value? What? No, you can't. That's right. It's 2 absolute value of x, and then 2 times negative 1 is 2. So what does it mean to stretch by a factor of 2? What does it mean? What do I do to all the y values then? Okay, multiply them by 2. Okay. So we have, if I take negative 1, my vertex, if I multiply negative 1 by 2, what do I get? Negative 2. So we take the y value, we multiply it by negative 1 times 2, we get negative 2. What about these two y values here? What are they? What's the y value here? 0, right? Okay, what's 0 times 2? 0. Okay, so they're still there. Okay. Let's try these here. Okay, the y value here is 2. What's 2 times 2? 4. Okay, so these are going to be up here. All right, so now my graph looks like this. Oops, what did I do wrong? Oh, yep, it is, isn't it? Let's see this one. Should be there, right? No, that one was right. It was just the left one. Yeah. Right, there we go. Okay. All right. So vertical stretch means that I take all the y values and multiply them by that number. So all the y values have been doubled. Okay. So we can go to our calculator again and check to see if we did it right. Okay. So we take 2 times the absolute value and minus 2. Okay. And we graph that. Okay. And if we graph our original one also, absolute value of x minus 1, okay, we can see that this graph that we just did is, what do we call that when it's stretched vertically like that? The lines are what? The slopes are what? Steeper, okay? All right, in this case, the slopes are steeper, and they should be. So basically, you can take the original, okay, stretch it out, and see what happens. Multiply those values.